Today we are going to discuss the topic spirometry and flow volume loops. So we are going to discuss first of all we are going to discuss this topic very briefly. We are going to see the important points necessary for competitive exams. Okay, that's what we are going to see. So what are these two images which you are seeing now? The first one, what is it called as? It is called as, just a second, what is this called as? It is called as spirometer. And what is this test being conducted here? It is PFT, which is nothing but pulmonary function test. Okay, so we are not going to go in detail of the mechanism of the spirometer or not the pulmonary function test, but what we are going to see is the graphs which is usually given in our exams, particularly in competitive exams. Okay, so we are going to discuss that in detail. Okay, let's see the spirometry graphs. Okay, so let's see what are they. So let's see first about spirometry. So here basically we are going to deal about the lung volumes. Okay, we are going to deal about the lung volumes. Okay, there are many volumes, as you know, which is nothing but inspiratory reserve volume, tidal volume, expiratory reserve volume, functional residual capacity, right? Then have vital capacity. Okay, so these are the volumes. So let's first see what is this graph which I am going to deal about. So let's draw it. As usual, I am going to draw the diagram and explain so that it will be easy rather than downloading and putting a diagram. Okay, so let's draw the graph. We'll draw here itself. I think I have space. Yes. So let's draw it here. So what is the y-axis and what is the x-axis? So the y-axis is, let's draw it here, it is volume measured in liters. And what is the x-axis? It is time, unit is seconds. Okay, so this is the axis, the x-axis and the y-axis. X-axis is time and y-axis is seconds. Okay, so now we are going to draw this. See guys, first of all I would ask you to put two lines at the center. Okay, two lines. I'll draw it in pink. Okay, or I'll draw it in blue itself. It will be easy. See, I'll ask you to put two lines at the center, two horizontal lines. Okay, these lines are the reference point to draw this diagram. Okay, might be in your university exams or wherever you want to draw this. You can easily draw it by putting a reference line. Okay, so what is this reference line for? See, first, see, I just draw it. You see, okay, first you are drawing a loop in this reference lines. Okay, then what we are going to do is, okay, now try to draw a dotted line at this lowest point. Try to draw a dotted line. Okay, there should be some space. Now let's see. That's all guys. This is what. So you can easily remember this flow volume, the spirometry graphs, right? Okay. Flow volume loops is different, but it's like the same similar things, but the x-axis and y-axis will be it will be interchanged. Okay, let's see that. Okay, what is it? This pink line which we have drawn here, no, in between the reference lines, these are the tidal volume. See, I'll just denote it. This is tidal volume, right? Next, what is this peak point? No, see, this peak point, what is this? This is the IRV. I'll just name it. Let's see in detail in the next page. So this is IRV. Okay, next, what is this? This is ERV, which is nothing but expiratory reserve volume. Okay, next, what is this tiny part here? I asked you to draw a dotted line, right? What is this tiny part? This is RV. It is not reserve volume, it is a residual volume. Okay, yes, this is a residual volume. Next, what we are going to see is, see, now I am going to draw the combined volumes. What are they? Let's see the first thing. See here, I am including this IRV, I am including this TV, tidal volume, and I am including this. I'll just go back. See, IRV, tidal volume, and I am including the ERV. See, I am including the ERV. What is this? This is VC. What is this VC? That is vital capacity. Next, what I am going to draw is, I'll rather try to put a bracket so that it will be easy, or I think this itself will be okay. Now ERV and RV is there. So what I am going to draw next is FRC, which is nothing but the functional residual capacity. Next, one more is, see, just exclude the ERV from this vital capacity. This will give rise to something called as IC, that is inspiratory capacity. And next, include all. This is nothing but the TLC, that is total lung capacity. Okay guys, so let's discuss. Okay, the next page. See, I'll just write each and everything. First guys, first TV, or I'll write like this. See, first tidal volume, in bracket I'll write. Just remember the abbreviations. So tidal volume. Second, what we saw, it is inspiratory reserve volume, IRV. Third one is expiratory volume. I'll just say what these volumes are orally instead of writing, so that it will be easy for you to just remember it. Okay, instead of writing, it will be just easy for you to remember it. Next, what are you going to see is residual volume. Next, the combined volumes. It might be right in a different color. What are they? They are, first, inspiratory capacity. Next is expiratory capacity. Next, vital capacity. Next, functional residual capacity. Next is total, sorry for this, total ouch, lung capacity, right? TLC, okay, FRC, VC, okay, C, E, C and RV. Okay, so what are these volumes? I'll just explain in brief. Guys, see here, tidal volume is a normal volume which we breathe in and breathe out. Again, the normal volume which we breathe in and out. Okay, this is the tidal volume, guys. So normal respiration which occurs both inspiration and expiration, no? This approximately produces 500, that is we breathe in and breathe out, that is nothing but 500 ml of air. Okay, this is, what is the volume of this? It is 500 ml. Okay, next, what is the next? That is inspiratory reserve volume. See guys, while we take inspiration, you know that there is a normal inspiration which we do, and the maximal amount, see there is another maximal amount which we can do, that is the maximal amount of inspiration. We should not confuse, there is many other things like forced expiratory volume and stuff, so let's not confuse with that. See, this is the inspiratory reserve volume, that is, just remember this word reserve. So you know, it's a extra volume which we can take in while there is no there is no proper supply of oxygen, no? At that time we can use this capacity of our lung to respire, right? So this is inspiratory reserve volume. Next, the same thing goes with expiration. So there is an expiratory reserve volume, right? It's the additional volume. It is the additional volume which we can respire. Okay, next there is something called as residual volume. Even after something called as forced expiratory volume. Okay, what is this forced expiratory volume? I'll just explain in the last. I'm not writing it. Why? Because it might be a little confusion. So what is this forced expiratory volume is when you try to expire maximally, the maximum amount, okay, the maximum amount which you can expire is this forced expiratory volume. So what happens at that time is, even after that, there will be some amount of air left in the lungs. Okay, there will be some amount of air left in the lungs. That is this residual volume. Okay, yes. Now these are these combined volumes. Okay, so this combined volumes is just a formula, but let's see what are these basic volumes only. Okay, this is what we need to know. These are formulas which I will be writing. So first let's see what are the amount, that is amount of or volume of air of each volumes, basic volumes mentioned here. The first one is tidal volume is about 500 ml, right? And inspiratory reserve volume, it is approximately, I don't want to write normal this value, it's an approximation, I'm writing it, that I'm just writing the range. Okay, it's 1900 to 3300 ml, right? What is this expiratory reserve volume? It is 700 to 1200 ml. And what is this residual volume? It is again 1200 ml, right? So these are the values. Just write it properly. This is 1200 ml. Okay guys, right? See, 500 ml, 1900 to 3300 ml is IRV. Expiratory reserve volume is 100 to 1200 ml. Residual volume is 1200 ml. Now let's see this combined volumes, right? I'm not writing the value, but I'll just write it, the formulas. This inspiratory capacity is nothing but, see, let's first see the diagram. See, What is this? Where is inspiratory capacity? This is inspiratory capacity, right? You see that, see here, it comes from here to here. So what does it include? It includes tidal volume. Yes, this is a tidal volume, right? See here. Plus, what is this? This is that IRV. So, IC is equal to IRV plus TV. Okay. So, this is the formula. See the graph here. This is this IC. See that carefully. Tidal volume is included plus IRV. See, IRV is this, no? So, this IRV is also included. See here. Okay, so this is inspiratory capacity. So let's draw it here. Let's write it here rather. See, what is this? IC is equal to, maybe I could have given a little bit space, but I'll just try to write here. IRV plus TV. So what is expiratory capacity then? What is expiratory capacity? See here, ERV plus TV. See here, this is ERV plus TV. I think I have not mentioned it. Have I mentioned it? Oh no, I have not mentioned it. Just a second, I'll just write it here. Okay, this is EC. Okay, see here. See here guys, see this is ERV plus TV, tidal volume. So this is expiratory capacity. Okay guys, I'll just write it here. So what is it? It is ERV plus tidal volume. Next, what is vital capacity? As well drawing in the diagram itself I said it. See, it includes IRV, it includes this tidal volume, and it includes this expiratory reserve volume. See here. See, it includes IRV plus tidal volume plus expiratory reserve volume is vital capacity, right? Right, so let's write that. See guys, it is, let's write it here. For TV it's here, written here. Let's just see. IRV plus TV plus ERV. Okay, this is vital capacity. Next, let's see functional residual capacity. See, functional residual capacity is nothing but it's associated with expiration, guys. See here, expiratory reserve volume plus residual volume. This is functional residual capacity. Okay, guys, see the diagram. Look at the diagram and try to correlate. So this is ERV plus RV. Next, total lung capacity, as you know, include all the volumes. Include all the volumes in the sense, the basic volumes. See here, this is total lung capacity. What does it include? IRV, right? TV, ERV, and residual volume. So this is the total lung capacity. So it is nothing but IRV plus TV, ERV plus RV. How can we write this? Or it is, what is this guys? What are these? See this? What is this three thing? How can we write it? What is this three thing guys? It is nothing but, just a second, it is nothing but VC, right? Oh, I'm just writing the next formula. See here, this is VC plus residual volume, right? What is VC? IRV plus TV, ERV. IRV plus TV plus ERV. Or there is another formula. What is that? What is that? IC plus FRC. What is IC? See here guys. You can see here. This is IC, right? And what is this? This is FRC. ERV plus RV. Expiratory reserve volume plus residual volume is functional residual capacity, no? See here, I have written the formula here itself. Okay, plus IRV plus TV, what is that? It is inspiratory capacity. It is inspiratory capacity plus FRC, functional residual capacity. So you can derive this formula like this also. Okay guys, for the volumes, you just add these volumes. For example, take the mid volume like some 2500 or like that. You can take IRV as, and expirators volume you can take around 1000, and this is 1200. So if they ask what is inspiratory capacity, what will you do? Add this 2500 plus 500. So you can say like 2500 plus 500. So it's like IC is approximately 3000. So you can derive the volumes using this chart, right? Okay, so let's next go for Spiro. We have completed spirometry, right? So let's go for this flow volume loop. Let's go for that, guys. See here, let's add a new page. Yes, so this is flow volume loop. We're going to see flow volume curves, flow volume loop. Okay, so this is flow volume loop, guys. So now in the starting itself I said the x-axis and y-axis will be different here, right, from spirometry. So let's see what is this x-axis and what is the y-axis. See guys, the lung volume comes here. In spirometry it comes at the y-axis, but here lung volume comes at the x-axis, and next flow comes here. Unit is liter per minute, right? Guys, at spirometry I asked you to draw two lines at the center, okay, and one dotted line at the bottom. But here I request you to draw a single line, okay, a single line. I request you to draw a single line for your reference point, guys. Okay, so now you know this this line is used to denote, that is to separate inspiration and expiration. Rather, see, it's just the opposite which I wrote. See, it is expiration and inspiration. This confusion will come at every point of time, guys. You have to be really careful. See, the top one is expiration and the bottom one is inspiration. Now, how does a normal flow volume loop appears? That's what you're going to draw here. See, a normal flow volume loop. Okay, let's see, guys. See, this is expiration and this is inspiration. So this is a normal flow volume loop. Okay guys, see, this is, what is this? This is inspiration and this is expiration. So this is a normal flow volume loop, guys. So we cannot describe it with a single like we cannot say it as a circle or a trapezium or anything. It's like a loop, right? It's a loop. If you have seen in ventilator machines, you can definitely see this loop. You'll be definitely able to see this loop. That will be in machines like dragger or anything. There is another machine also, like in these brands you can see that it will be in that right bottom corner. There will be flow volume loops. It will be constantly coming like this. It will be running like this. Yeah, you would have seen it, right? So this one is a normal flow volume loop. This is a normal flow volume loop. Okay guys, so now we are going to draw the individual, that is significant flow volume loops. So on the patterns we are going to see it. Let's see, I am not naming, the x and y axis, guys. I'm just going to draw the lines. Okay, so that is, I'm going to draw the loops. See guys, see here. See, there is another loop which appears like this. Okay, see, we saw that normal will be like this, right? There will be nearly a semicircle, but see here, it is reduced. So what this loop is, so that's what we are going to see. So this loop is nothing but, I'll just write it. Yeah, I'll just write it. I'll use the same color, yeah, white. So this is variable this is variable extrathoracic obstruction. Why extrathoracic? Because the affected loop here is inspiratory loop is affected, guys. See here, the inspiratory loop is affected. So what does that mean? As we know that inspiration, which contributes mainly for inspiration, it is the external intercostal muscles, right? It's the external intercostal muscles. So which is affected here? It's the extrathoracic obstruction occurs here. So next we are going to draw the next curve. See guys. So see guys. Now we are going to draw another loop. What is this? See here. What is now flattened? What is now flattened, guys? See here. What you can see? See, the inspiration is normal and the expiration is affected. So what is this? It is variable. I write it in the same color. It is variable intrathoracic obstruction. Okay, it's variable intrathoracic obstruction. And these two patterns are very main. The next two patterns, right? See guys, these two patterns are very important. Please see here. See guys. See, there's something in this inspiration. Something in this expiration, sorry. There's something. What is this? This, you can see that there is a scooped out pattern. See, if you take something, you just scoop it out, right? So normal expiration curve appears like this, but here this is a scooped out pattern. So this is a scooped out pattern. So what is this scooped out pattern, guys? What diagram is this? This is nothing but, it is the flow volume loop seen in obstructive lung disease. And the pattern name is scooped out pattern or dog leg pattern. Right? Right. So the next one, what you are going to see, it is, see guys, again you are going to draw. But now what happens is, okay, I just take this color. See here, the expiration seems to be normal and even the inspiration is normal. But what is this? What abnormality is here? See what abnormality is here? So you can see that it is a miniature version. See, this is a normal inspiration expiration curve, but this is a miniature version. So what does this show is a normal inspiration and normal expiration. The loop is normal, no abnormality in the shape, but there is an abnormality in the size. It's very small. So what does this denote? It is restrictive lung disease. Right? This is restrictive lung disease. Rather, you can just name it as miniature version of a normal loop. Miniature version of normal loop. Next, we are going to add another page. Right? And what you are going to see is probably the last flow volume loop for the day. See here, guys. See here, guys. There is an abnormal inspiration. Yes, abnormal inspiration and abnormal expiration. So what is this, guys? What can this be? This is nothing but the flow volume loop of tracheal stenosis. Okay, guys, this is the flow volume loop of tracheal stenosis. So can we discuss what we saw from the first? Yes, guys, see, first we saw about spirometry, right? See, this is a spirometer, this is a spirometer, and this is pulmonary function test being performed. There are many significance in this pulmonary function test, so let's discuss that in another class. Now see here, this is spirometry. So guys, these are the topics which we saw. So what are the topics? First is spirometry and flow volume loops. We saw what is the spirometer and what are these pulmonary function tests. There are many significance, so let's discuss that in another video. Next, see, this is a lung volumes which we saw, right? This is a graph. First we are drawing it. Know how to draw this diagram. It will be useful in your final exams, right? See here, we are just drawing a reference line. Next we are marking something in between these reference lines, that is the tidal volume. And next there is one peak and one what is it, trough or one low point, which is nothing but the inspiratory reserve volume and the expiratory reserve volume. And here also we are drawing a dotted line, which is nothing, which is used to denote the residual volume. Okay, guys. Next, tidal volume. See, this is approximately 500 ml. Inspiratory reserve volume 1900 to 3300 ml. Expiratory reserve volume 700 to 1200 volume. Residual volume 1200 volume. So we see the what is it, formula? IRV plus TV IC, that is inspiratory capacity. ERV plus TV is expiratory capacity. Vital capacity is IRV plus TV plus ERV. Next, functional residual capacity is ERV plus RV. Next, total lung capacity is IRV plus TV plus ERV plus RV, or you can say it as functional residual capacity plus inspiratory capacity, or vital capacity plus residual volume. Next, we see the flow volume loop. See, this is a normal flow volume loop. You can see the inspiration and expiration. Main thing we have to remember is inspiration comes at the bottom, expiration comes at the top. Okay. Next, this denotes that there is something abnormal in the inspiration. Just remember it as an opposite. It's variable extrathoracic. Intrathoracic obstruction, you can see that the expiration is abnormal, right? So that denotes variable intrathoracic obstruction. Just remember it is opposite. See, if Expiration means intrathoracic obstruction is there, and inspiration abnormal means extrathoracic obstruction is there, right? Okay, next. See, in obstructive lung disease, there is a scooped out pattern or dog-leg pattern. So there is obstructive lung disease, and restrictive lung disease, you can see that there is a miniature version. This is a normal flow volume loop, but here you can see a miniature version. Otherwise, the inspiration and expiration seems to be normal, but it differs in the size, not in the shape. Next, you can see that both abnormal inspiration expiration, there is nothing but tracheal stenosis. So that's all for today, guys. Have a good day.